Hi there, Algebra 1. Patterns and linear functions today. Objective to identify and represent patterns that describe linear equations. Okay, first off, we have dependent variables, change in response to another variable. Independent variables are called inputs. Outputs, the value of the dependent variable. So, I think I mentioned this yesterday in your lesson about the fact that, and it might have just been in school, not on these videos, but the fact that the x and y, or the variables yesterday, could be direct or indirect. A function is a relationship that pairs each input value with exactly one output value. Linear function is a function whose graph is a non-vertical line, or non-vertical line, or part of a non-vertical line. So, in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? Represent this relationship using tables, words, and an equation and a graph. So, today is going to be kind of a busy one on that aspect of things. Okay, so, first thing we have here, is we have one rectangle, which is 1 by 6. Then we have 2, which is going to be 2 by 6. And 3 by 6, and yada yada yada. In the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure they form? So, perimeter. Okay, our formula for perimeter is length, so 2L plus 2W. Okay, in the first one, so when we have 1 rectangle, you are going to have, so 1 rectangle. Okay. Okay, so then I'm going to plug in, when I have 1, I have length is 6, so 2 times 6 plus 2 times 1. And so my perimeter Alright, so my perimeter is about 6 plus 2, which would be 14. Okay, I do 2, I'm going to still have 6, or 2 times 6, plus, well then it'd be 2, wouldn't it? 2 times 2. So I'm going to get 12 plus 4, which is 16. Alright, I'm going to have 3 the next time, so I'm going to have 2 times 6 plus 2 times 3. So you're going to get 12, 18. And with 4, you're going to get 2 times 6 plus 2 times 4, which should get you 20. Okay, so there is my table. I've created that so far. I need to use words now. Okay? And also, this is like my x and y value. So, this is going to be my x value. This is going to be my y value. So what it really doing in this one is multiplying the number of triangles by 2, giving us the distance of the top plus the bottom, and then we add 2 times 6 for the top. All right, that would be my words. Okay. Okay. I still have an equation to create. And I still have to graph this. Alright, equation. Well, realistically, what's happening every time? Well, this happens every time. So I know I have 12. I know I have y equals, okay. My variable here is w, so it'd be like 2w plus 12 every time, right? And then whenever I plug in for w, which was going to be my x value, that is my equation. Okay? So, basically, this happens every time. That's why I got 12. 2 times whatever my rectangle side was that. So I'm going to leave my rectangles as x, take it times 2, add them together, and it works every single time. Okay, now you have to graph this. So I'm going to get rid of those. Okay, I want to keep my chart here. Okay, I'm going to go by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, this one can go over by 2, sure. Okay, so at 1, I am at 14. At 2, I am at 16. At 3, 18, and 20. Okay, that would be my graph. Okay, now we got the one with the triangle. Suppose that you know the perimeter of n triangles. What would you do to find the number or the perimeter of n plus 1 triangles? So, this one's an interesting one. Okay, so I think we want to do the exact same thing we did up on the top one here. Okay, we need the perimeter. Perimeter is adding up all 3 sides. Obviously, with the triangle, this is our isosceles triangles, which helps a little bit. So let's go 2s plus 4. All right. Number of triangles. Good. We got 1 here. Over here, we're going to have perimeter again. All right. So we plug this in. The first one we have one triangle. Oh, and this. Alright, so we know that our sides is going to be 2 by 3, or there's going to be 2 sides of 3, so that gives me 6, plus 4 times the number of triangles, which gives me 4, so my perimeter of the first one is 10. Second one, I have 2 times 3 again, okay, and I have 4 times 2, which is 8. Three, I have 6 again from that, plus 12 is 18. 4 is going to be 6 plus 4 times 4 is 16, is 22. So there's my table. Okay. Words, you'd be taking your sides times 2. And then multiply or adding the product of 4 times t. Okay, I'll double check to see, because we actually right now are just looking for okay, so, if I had to put this in words, I'm going to say multiply the number of triangles times 4 and add 6. Okay. The equation in this case would be y equals 4t plus 6. Okay. The other thing that I have to create here is my graph. I really wish I would have kept my last one. We're going to go ones this way. Alright, so we're up here at 10. Then we're up here at 14. Then we're up here at 18. Then we're up here at 22, which would go into my other part. Okay, so there's my graph. Now, the one thing that it asked, so I've done everything that it asked for up until that point. So this would help you create so you know what to probably do in the next video. It's nice because now my equation gives me it to where I can find the next term in this set. Oh, gotta unfreeze. Alright, the table shows the relationship between the number of photos X you take and the amount of memory Y in megabytes left on your camera's chip. If the relationship using a linear function, describe the function using words. an equation, and a graph. So, this one. So first off, you have megabytes, you have 512 with 0 photos. Okay? So, every picture you take is +1. Okay, I have to put this in words, and I have to put it in an equation, and I have to graph it. The thing that I'm seeing here in my graph is the fact that every time I take a picture, I'm losing 3 gigabytes. So, my initial value is 512. To find out how much memory I have left, I'm going to take 512 minus 3 and y, because I don't know how many photos I took. Oh, no, x. And that's going to tell me what I have left for memory. I created the equation right away. The equation makes more sense to me than words do. So, trying to think what I want to do. You start with 12 or 512. You start out with 512 megabytes of memory. After or minus 3 megabytes per photo taken. Okay, did the words. Graph. I really don't like this graph. Without a break, this is actually kind of a hard one to do. It should look something like that. Okay. Have I answered everything they want though? Is the relationship using a linear function? Yes. The reason for that is because you are always the picture's memory is not changing. You will go down to a constant rate until your memory is gone. And as you can see from my graph, it looks pretty linear. It's following itself all the way down. So yes, it will be a linear function. All right. In the relationship in the table below, a linear function, describe. Is the relationship in the table below a linear function? Describe the relationship using words, an equation, and a graph. Okay, so you have 8 at the beginning. Is it a linear function? Okay. At time 0. Okay. So at the beginning there is 8 Actually, I think I'd be better off creating an equation, to be honest. And the reason that I like creating an equation first is it's a lot easier to put it in words, my opinion, after I have created an equation. So yes, I do think this is a function based off of looking, but I'm going to create the equation first. So, the equation to make this work would be y equals y is going to equal, let me fix something here. Found an error when I was looking at it. Alright, so your output's what? So, every time we're adding 2, right? So if I take 2 times n plus 10, does that work? Well, 0, not 10, 8. 0 is going to go in there, it works. Go 1, it's going to work. You go 2, you get 12, then it works. Okay, so what you are doing every time now is you're taking 2 times the input x and adding adding 8. Good. If I had to graph it, alright, 0, 0, 0's at what? 1, 2, 3, 4, 5, 6, 7, 8. Alright, 10 is going to be 1. 2 is going to be 12. 3 is going to be 14. So it would look like that. And yes, this is a function. You can see it. My graph isn't perfect, but it's pretty close. Obviously, we're going up by 2s, so that's pretty good. A function actually is a linear equation. As long as your equation is linear, so this looks like a linear equation. It looks like our mx, our m equals mx plus b, then yes, it will be a function. That is a key to knowing for sure if it is a function or not. There is your homework.